All right, so we're going to look at the 3D applications of the Pythagorean theorem. And this is so relevant when you need to, like the box companies, like the UPS store, FedEx, Kinko's, all those places, when they put together a box, or even Amazon does it, and they do a very bad job of it. They don't take the time to do math, they just do it. But if you did some math, you could cut that cardboard to fit exactly what you needed based on the diagonal length of a box. So it's kind of cool. So here's an example. Lindsay wants to mail a candle, and it's 8 inches tall. It's for her friend's birthday. She has this box here that's dimensions 3 by 4 by 7 that you see pictured. And she's thinking, will that candle be able to fit in there? So if you think about how it could go diagonally, and we know that that box is, it's rectangular prism, so it has right angles in every corner. And we know that a square or rectangle cut down the diagonal like this rectangle cut down has 2 right angled triangles. And the airspace, so you can see I've kind of tried to shade it in so you could see the diagonal right triangle. So when the back edge meets the bottom of the box and you go straight across diagonal of the box, this is your right angle in that corner. And so we have to find this diagonal first in order to find the space diagonal there. So finding the diagonal across the middle of the diagonal of the bottom of the box, then I have a leg and this leg to find the hypotenuse for that box. So we're going to look at some examples for that. I went ahead and did this one, worked it out, and first you have to find, like I said, the base diagonal. So I did 3 squared, 4 squared, square root of, and it's 5. So this is 5 inches. Now I have a base for my green triangle. So it's 7 squared plus 5 squared, square root of. It's a radical 74 is its exact amount, approximately 8.6 inches. So her 8-inch candle will fit because it could lay across easily. It could make it across the diagonal and with some room to spare. Okay, I've gone ahead and drawn out on the first one. It says to round your solutions to the nearest tenth because they're not going to be perfect squares most of the time. So it says to find the length of line AB. So you can see that's that space diagonal right there. I love that name, space diagonal. So I'll write that down here, make sure we can all remember that's called the space diagonal. Space diagonal, because it's in space. It's not concrete, it's in the space. Like the space of the box, but air space, like outer space. Anyway, I highlighted so you could see the 2 triangles we're looking at. First, we have to find that diagonal across the bottom of the box. It's 13 by 16, 13 square and 16 square. Exact amount, radical 205, approximately 14.3 inches. So I can use that for this diagonal here, 14.3 squared plus the side 13 squared, square root of. It's approximately 19.3 inches. So that is the space diagonal. The line AB is approximately 19.3 inches. So I'm going to give you a minute to look over that if you need to, process a little bit. And then I'd like you to get started on number 2. And then come back and see if you're understanding or getting the hang of it. If you know you're not quite ready for it, take a minute to study 1, try to process through it for 2, and then come on back when you're ready for more. How'd you do? Were you able to envision it? This one was a little harder to draw. And of course, if you use a highlighter, it really does kind of bring out the shapes a little bit in the 3D section. As opposed to a solid color, it kind of helps you get the dimension in there. I love how it makes it pop. So take a look at this for now and work it through yourself if you didn't get the same result. And I have a question for you. Could I use the exact amount here to find my space diagonal? And if I did, how different would this answer be? could I use 8 radical 10 instead of 25 and 3/10 to find my space diagonal? And if I did, how much different would my space diagonal measure be? So give a minute of thought to that. So pain, right? It's a real pain to put that in your calculator the correct way, to have to get a radical, and you have to put it in parentheses so it knows what you're squaring. And thank goodness we don't need to, because it ended up being the same rounded to the 10th. So just an interesting thought, because this is the exact and this is the approximate. So just an interesting, sometimes that can make a big difference, and other times it may not. So let's move on and let's take a look at this last, number 3 on this page. In the prism shown, AC is 12 centimeters. So let's mark that 12 centimeters. Still not having my stylus. And CD is 5 centimeters. BD is 2 centimeters. Okay, I marked that on my visual here. We're going to decide what's true and what's false here. And we're going to rewrite any false statements correct. So the length of AD is the square root of the sums of 12 squared and 2 squared. So decide if that's true or false. If it's false, rewrite a true statement. And then B, the length of AB is equal to the length of AD. True or false? If not, if it's false, write a true statement. I'm going to pause now. I'm going to work out to find that diagonal that we need to know. I'm going to look over it. I'm going to think about it and decide what I can write if those are actually false statements. Hopefully you found that they're both false. So AD, let me get my arrow here. AD is that hypotenuse across the bottom, the base rectangle. And its dimensions are 12 by 5, not 12 by 2. So I rewrote that the line AD is equal to 12, the square root of 12 squared plus 5 squared. And then I went ahead and finished it out, which I didn't need to do, but we're going to talk about that in a minute. And then the second question is also false, and it says AB is equal to the length of AD. Well, think about it. This is a right triangle, and we know the hypotenuse is the longest side, and it's going to be greater than either leg. Okay, so I did the math to prove it to myself. It's not a lot bigger because there's not much altitude to that box, but it's not the same, and it's not going to be in a right angle. So hopefully you've got statements of your own that you wrote in your own style of feedback and writing true statements.